now that I'm looking at the code, state the problem again.
Okay, so this works. This will create an attribute called original that has a moo version of the data frame, the original.
Yes, that should be
stored within
the
object itself. That's kind of strange. The object is a data frame and it stores a copy of itself for reference later.
Yeah.
Okay, but the weird thing is, if you try to do this trick with the init method, it creates like a loop, because when you initialize, you try to store the original as a moo object. And to do that, you have to create a moo object, which is going to try to store a moo object.
Okay, so what you ought to do then, what you ought to do is line 28, you want to split it up. So instead of saying object equals CLS parenthesis, that whole thing, you say that whole thing, well, that whole thing is just calling pd.pandas.readcsv, right? So you take that on the previous, say what's in CLS parentheses, take what's in the parentheses, move it up one line. So you're creating a new line between 27 and 28. And you're going to say df equals pd.read_csv. And then line 28, blah, blah, blah. And then what is currently line 28 will become object equals CLS parenthesis df. And then what is now currently line 31 will become object.original equals df. In fact, you could even remove, code compress it a little from that, but that's the basic idea. Does that all make sense? Because right now,
remember this code works.
You're making a deep copy of object, but object is not, and look at line 28. What's the type of object that you're creating? You want it to be the reference to the original data frame, right? But you're casting it with CLS to something that's not a data frame. So that's why that's why you're getting this infinite recursion, because you're passing it to if you do this, it bypasses that completely. Does that make sense? Or do you see something I'm missing? That's also possible.
So in the way this code is written right now, it actually works.
Oh, yeah?
Yeah.
Oh, okay.
But if you move this kind of stuff to an init, then you do run into that infinite loop problem. So it seems like it's impossible to store a copy with the same class in an attribute during initialization.
Can you show me what that init code would look like? Under init code would look like?
Oh no, I messed it up. Sorry.
Yeah, it was.
Something like that.
Instead of saying on line 38 or 39, stop moving it.
Okay.
Yeah, I'm just kidding. On line 39, instead of saying self.dunder class, could you just say pd.dataframe?
Yes, that would create a pd.dataframe, which I agree will solve the problem. But what if you wanted it? What if you wanted it to be a moo?
Oh, so sometimes when you instantiate moo, like, is it sometimes you want one and sometimes you want the other?
Ideally, it would just always be a moo. Actually, if
so you do want it to be a moo. You don't want self.original to be a data frame instance. You want it
Yeah.
to be an instance of mu or whatever the
Right.
subclass of
Mu is-
hierarchy is.
Mu is basically a data frame that can do extra stuff. So yeah, I would like it to be.
Oh, I see. Gotcha. Okay.
So
Well,
you mentioned typecasting it to a pd.data frame, but actually the weird thing is when deep copy returns a copy of this object, which is a mu. Oh, sorry, this should be self.
okay.
When it returns a copy, it actually returns a pandas data frame, which I think is very strange. So deep copy is copying a mu and it returns a pandas data frame. Why is that?
Oh, interesting. So self.original on line 39 there is not an instance of mu, it's an instance of data frame, huh?
Yeah.
You're sure? I mean,
I could be wrong about this stuff, but
are you? I mean, if you're capable of, you're certainly competent enough at this that if you say you're sure, I will take that as true. I just want to double check because it seems weird. How confident are you? Pretty confident?
I'm checking right now.
Okay. It's a kind of thing like if I encountered this, my first thought was, wait, I confused myself somewhere. Let me double check.
Yeah, definitely.
One way to do this, which may not be what Tim needs to do, by the way, but just for everybody listening, it could be, I find assert is instance to be useful in scenarios like this. So one way to be confident is that on line 40 here, for example, you could say assert space is instance self comma the class you want to be. And that's a good usage of a defensive assert for this because it'll be quiet when you run their test or you run the program. It'll be quiet if that thing you're assuming is true is actually true. And if you're living in an illusion and it's not actually true, it'll let you know. So that's
what's the order on is instance? Is it
object and then type? And do you want it to be? Oh, is that just auto completing? Because you don't want it to be data frame, right? You want it to be mu, right? Is that true?
Yeah, that's
okay.
What? Okay.
I think that'll work. I'm pretty sure that'll work. If not, you could say self.dunder class, but I'm pretty sure the symbol mu will be defined by the time that dunder init method is executed.
Okay, so I'm just going to run PyTest because it's going to hit that eventually.
Yep.
It all passed.
Aha. Change it something else like int, self comma PD. Yeah, that's fine.
Actually, this will pass too.
That'll pass.
That will pass too. Yeah.
Let's see if we can watch it fail. So change it to that should pass. Did it pass?
Yeah, it passed.
Change it to int. Int. That should fail. Now run it. See what we're doing, the strategy here, everybody, is I have a test and I want to make sure the test is correctly failing when it should failing. Like a correctly written test, whether it passes or fails has nothing to do with whether the test is correctly written, right? So, okay, good. So we did get an error. That was what failed, right? Okay. Yeah. So good. So now you can change it back to mu. I just wanted to make sure we were hitting it, right?
Yeah.
Okay. So now what's the problem?
Now it seems to work.
Go away.
We can create a mu and save it as itself.
Okay, good. Okay. So somehow we stumbled.
Hold on.
That's good.
I just want to check one.
Okay, if you got something else, let's dig into that.
Let's drop a breakpoint here.
Okay.
Run PyTest, hit the breakpoint, and then we have self. We can find out what the type of it. Yeah, it's a mu.
Okay.
But what about self.original? So
that's the way it should be, right? Or no?
No. So
no, you want it to be a mu?
Remember, we just asserted that that the thing that was stored in self.original was moo?
No, we asserted, what was it? Show me the code again.
Oh, we did self. Oh, that's what we should have done.
Oh, that's what it is. So it should be assert self.original is moo.
Yeah. Yeah.
Okay.
Okay. Sorry.
It's okay. You want to kill the breakpoint?
Yeah.
Yeah, I missed that. But that's fine. Okay, good. Now we have, now we're getting somewhere. Because now we have clarity.
We all agree that this deep copy would, the most sensible thing is when it copies itself, it copies the object, including its class. Why wouldn't it copy its class? But this is proving that it didn't copy its class, right?
Let's make one change to 40. Append the following characters, please. Comma, space, type, parentheses, self.original.
Where do you want me to do this?
After the closing parenthesis, after MOO closing parenthesis, add comma, space, yeah, like that. Type, parenthesis, self.original. And now please run the test again.
Yeah.
And it says, okay, go scroll down, please. Yeah, see where it says there, error tests, class pandas core frame dot data frame. Okay, so that assertion error is giving us in the stack trace basically what comes after the comma is displayed there for us to see. That tells us that the type of self.original is a data frame. Okay, so that's a generally useful technique, and it's useful for us here right now.
Wait, I don't understand. I don't understand what you did. So
let me explain it real quick. So the syntax of the assert statement is assert space expression. That is syntax number 1. Optionally, syntax number 2 is assert space expression, comma, another expression. Okay, so, and that other expression will show up in the stack trace if it's supplied. If it's omitted, if you say assert space expression new line, then the stack trace will just say assertion error. It will not say anything about, it will not have any other information other than the line number. So that we're passing additional information about what's going on in the stack trace generated by the assert statement. Because if we say assert is instance, this object is of this type, and if that assertion fails, what's our first question going to be? Our first question is going to be okay, well, it's not a moo. What is it then? Right? And so then we lose Tim. He's the star of the show. Where'd he go? Okay. Well, hopefully he'll show up again. So that basically so I've had him put that in there so that I had him put that in there so that we would clearly know exactly what the type was. Because if we are assuming that it was a data frame, but maybe it was not, that would really mislead us trying to debug this. So I have that added in there. And just one thing that's important to understand with when using assert statements like this is that there's kind of a syntactic landmine. Imagine if you say assert parenthesis expression, comma, another expression, close parenthesis. Python interprets that as assert single expression because assert, it basically parses it like assert space tuple open with a parenthesis, A, comma, B, close tuple. It's like assert tuple expression, which will evaluate if it's, has the tuple has more than 0 elements in it, it will always evaluate that true. You have a useless assertion that always passes, and it's just a silent landmine. And so watch out for that. A good linter will tell you about it, but that's it. Well, it's all the time we have, everybody. Thanks a lot. I'll see you next week. Just kidding.
Sorry, I lost my computer.
Yeah, that's okay.
Okay,
So yeah, I was just I think you caught most of the assert thing. Basically, it's assert expression, comma, additional information expression that will show in the stack trace.
Okay.
Make sense?
Yep.
Okay. Now let's look at your code again. And can you make it so that I see like now like 20% of the screen real estate is available? Yeah, if you can fix that. Let's see. We don't need to see the that either. Okay, so the problem is that line 40, that assertion fails. And we want it to pass. Is that correct?
Yes. Yes.
Okay. Is
But-
there anything else?
Well, just this curiosity about why deep copy wouldn't give you
Yeah, well, that's yeah, but I would say that question is encapsulated in the assertion on line 40. So that's really the question we're yeah, so we just want to know why deep copy of self is returning that. Now why would that be?
Is it because the only init that's been called so far was on the data frame? And so as far as that whole object is initialized, so far only the data frame init's been called?
That could be the reason. Yeah. I mean, I'm honestly not exactly sure because I've never quite seen code like this. But that seems like a really reasonable explanation to me.
If we move that super init after the assert, would we just get back an object at that point?
I don't think it would make any difference because basically the object called self in this scope has already been created, but it's not you know, dunder init in a way is kind of like just an ordinary method, except it has special semantics of being automatically invoked when the object is created, but it doesn't. Is it possible that it changes self.dunder class? I don't believe so, but I also would have predicted that self.dunder class would be. It's got to be moo actually.
Yeah,
Let's
I
see
agree
here.
that the class of self has to be moo.
Maybe assert that or breakpoint, either way. Let's check. Either breakpoint or assert, your choice.
Good.
So, well, class has two S's
Oh,
first.
so sorry.
And then, actually, here, do this. You know what I would do in this situation? Here's a trick I use, which is a little, I can't say it's really elegant, but it's useful. I say on line 41, I would say assert space false, comma, self.dunder class.
Oh, okay.
And then get rid of, yeah. And then run that. And of course it will fail, but we'll see information in the stack trace. What do we got? It's moo. Okay, yeah, that's good. Okay. So yeah, so yeah, so
we have a moo object, we deep copy it.
so we
and
do,
have a
yeah,
pandas.
so you can erase line 41 because now we know. So yeah, I don't think, what in the world is going on then? Deep copy is returning. Let me look up something. Hold on.
While you're doing that, I'm going to chat GPT why deep copy works like this.
Okay, let's see if I can, yeah, let's see who wins. It might be that date. Oh, I bet you $1. I know what it is. I bet you data frame implements its own deep copy method.
Oh, that would be weird.
Copy. Because when that happens, yeah, so there's because I'm looking at the documentation for deep copy, and here I'll just read what it says. The deep copy function avoids certain problems like recursion by letting user-defined classes override the copying operation or the set of components copied. And then the mechanism for that is described later, but there's like Pandas has, let's see here. Pandas has its own copy method. And I'm also wondering if it has a dunder deep copy method.
But hold on a second. So
yeah,
we're the way that the syntax for deep, the way the syntax for deep copy is written, it doesn't look like that's going to go through. It's not going to make the call to self. I don't know. Maybe it will. Is it going to call self dunder deep copy or something?
Well, I think what'll happen, and I'm still checking this, but I think that data frame has a dunder deep copy method, which the deep copy function in the copy module will honor that. And I'll bet you that data frame.dunder deep copy calls its method called copy with the flag to true. So, but so far that's speculation about the dunder deep copy. So I just put in a link in the chat to dataframe.copy. And now, it has a link to the source. Let's see if we can see if there's a dunder deep copy method.
If this doesn't pan out, I've got another idea.
Okay, hold on. I want to hear your idea, even if this does pan out. Oh, yeah, check it out. Okay, guys, look what I found. Hold on. So there's yep, it's exactly like I said. I am a genius. Okay, so yeah, there's so data frame has a method called dunder deep copy, and that magic method is utilized by copy.deep copy, which is what you're using there on line 39, and then that will then override everything. So basically, you're calling moo.dunder deep copy, which returns a data frame object, apparently, because it looks like def copy. So def copy is a couple of methods before that second link, which is a link to the source code, and then I bet you it's just calling something's code that is hard coded to return a data frame. So I think what you just need to do, the practical thing is to do what you originally did, which is to wrap the right-hand side of 39 around when CLS, like cast it to moo, basically.
Okay, so if we do that here, right?
Well, no, you could, but that would be, then if you rename moo, then you can have problems. I personally would use self.dunder class parentheses. Yeah, like that. So close, so run the test and let's see if that passes. Oh, and uncomment 41. I'm sorry, uncomment 40, line 40, because we want, that's our protection, right?
Okay. So maximum recursion depth.
Oh, right. We have that problem. Okay. But we did not have that when we're just deep copying.
Up here.
I see. No, well, I mean, when we did not wrap it in CLS or cast it with CLS. Hey, Mark, what was your idea?
So I think this kind of goes back to the method resolution order. At that point where we're doing the copy of self, it still has all the properties of a data frame. It hasn't accessed anything move specific. So it still looks like a data frame since we inherited from that. But I'm wondering if you set like self.original equal to none before you did the copy, all of a sudden the class would say, okay, yeah, I'm a Moo class now, and then do the deep copy.
But I don't think
That's not how it works.
Yeah, I think when you initialize
MRO operates in a different. This is about like MRO has to do with when you're invoking a method on a completely finalized instantiated object, and it doesn't operate in the way you're suggesting here during the object creation, because even within on line 39, it knows it's a Moo. So unless I'm missing something.
Does it know it's a Moo?
Yes. Because remember, we even checked self.dunder class is Moo, right? It definitely knows it's a Moo.
After we accessed self.original, I'm saying before we access self.original, I'm wondering if it thinks self.class is the data frame.
No. Everywhere inside the body of the dunder init method that starts on line 36, self.dunder class is equal to the class object. And that just falls out of the semantics of how class instantiation works. If you think about it, it would be kind of a special kind of hell if, that value of that magic attribute changed from line to line, right? It doesn't do that.
Well, it's on the init. That's why I was wondering.
Yeah, it actually,
like
that's all set up before the init even starts. Because init is not really a constructor if you want to get really picky about it. Because in object-oriented programming, we talk about constructors. And strictly speaking, a constructor is something that creates the object in the first place. And in the theory of object-oriented languages, there's a distinction between the constructor and what's called the initializer. And the constructor is actually in Python's runtime. And the initializer says, okay, here's a fresh object, and we're going to configure it so it's in a valid state before we start executing code with it. That's what the initializer is. So technically, Python does not let you write a constructor. It just lets you write the initializer. That's what dunder init is. And this is kind of a picky distinction, which is why I basically never mention it. But relevant to what you're saying, Mark, it will definitely before dunder init here even starts, you do have an instance of the Moo class. It's an instance of the Moo class that does not have the lines of code in dunder init written yet, executed yet. That's the only, so it's incomplete in that sense. It's good. It's good thinking, but it just works. The way I just explained is actually how it works.
Yeah, here's the proof, Mark, that even before we do the deep copy stuff, it already knows it's a Moo.
Yeah. Okay.
And actually, even when Pandas data frame does its dunder deep copy, self is still a Moo. So I'm still looking at the source code to try to understand why it would end up being a Pandas data frame.
I bet you that there's it goes down. I'm looking in the source of the copy method of Pandas data frame. And it has there's a dot constructor method.
Yeah, underscore constructor, right?
Yeah, that's what I meant to say. Thank you for the correction. Yeah, so it's underscore constructor, which is doing something I'm not immediately understanding. Okay, so yeah, I mean, we can continue to go down trace down, but the thing is we can't really do anything about it because we're not going to patch the source code of Pandas, right? So
right.
What we're observing and measuring empirically here is that dunder deep copy returns, if you have a subclass of data frame and call the dunder deep copy method of that subclass instance, it will turn an instance that is not of the subclass, but of data frame. And I bet you it's just because data frame for optimization reasons is hard coded to do that. So that leaves us with back where we started, which is what do we do about all this? Well, first of all, you can delete line 39. We don't need it anymore. And then the second thing is we can let's see. So 39.
What if we implemented our own deep copy of ourself of the Mu object?
Well, the thing is, it's ultimately going to need to use the self-copying code in data frame unless we want to implement that, which ourselves, which I would not advise.
No, I just meant to make sure it returns a Mu object.
Well, yeah, that's what but to make that work, it's ultimately going to call dataframe.copy. And I don't see a good way around that happening. Do you? Maybe there is. Let's so if I'm missing something, please let's point it out.
A shallow copy would copy all other stuff, and then you could say, then
I wonder, that's a good point. I wonder if just a shallow copy would work well enough. Tim, what do you think?
So as far as I know, shallow copy gives you a copy with this original objects still referenced. So if anything changes, then you don't have the original copy. And the whole point of this is to
go ahead.
The whole point of this was to store the original untransformed state,
Maybe you should just save it as a data frame, not fight this. Just save it as a data frame, because I think you could then compare instances of Mu to instances of data frame if you needed to.
No, I agree. I just, when I hit this, I puzzled over it for a while because I couldn't figure out how to make it work.
It's an interesting problem. It's really cool. I'm really glad you asked about this.
I think there's one other strategy that could work. And that's basically store the call signature when initialization happens. So you'd have to use inspect or something to get the call signature. But if you stored the call signature, you could just eval it at a later time and get back the original object. It's
assuming that the data source from which it was constructed had not changed in the meantime, right?
Right. Yeah, exactly.
Which may not always be true.
Yeah. So of the two, I think just taking the Pandas data frame as the result is probably the better option.
Yeah.
It's certainly easy.
It's a really interesting situation. And the reason it's interesting is that it's surprising. And the reason it's surprising is because when you dive into the source of data frame, you see that it has its own deep copy mechanism that apparently is hardwired to produce an instance of data frame.
So I would argue that the part of the magic of Python in this case is why this problem is so hard to track down. So deep copy looks like some sort of almost like a keyword or something that's just available for acting on an object, but actually it takes the object and it calls dunder deep copy on the object to see if it wants to do something first, and then goes up the chain. It's just a little bit too magical and leads to some confusion. If we just used self.deepcopy, it would be more obvious, and then you would start thinking through like this, the MRO and going up the chain. I didn't even consider that Pandas would have a dunder deep copy. I didn't know that there was.
Yeah, it's like another little protocol that Python has. It's actually a protocol that the copy module provides, in the sense that says, if the object has this method, I will delegate to it.
Yeah.
And I think it's reasonable, because I think there are situations where you would not want a general algorithm for deep copying. And this entirely makes sense that a data frame is one of them, because, the data frame is not backed by pure Python code. It's built on top of NumPy. It's ultimately, there's Fortran code that is compiled into a binary object that is linked in and wrapped with layers that are wrapping layers until you can say just import data frame from PD. So it's reasonable to me that they would want to do it. It would be better if that deep copy implementation they have was able to provide return an instance of the actual class rather than the insisting on returning a data frame. And I don't know, that could have been an oversight on their part, or it could be that they're well aware of this even more than we are, and meaning the core development team of Pandas, and there's some technical reason it's just really hard to do. I wouldn't be surprised either way.
Mm-hmm.
So, I mean, I think enough people subclass data frame that seems like this might have come up before. You're not the first person to have experienced this situation, Tim. Yeah. I'm just looking through the data frame source more. So just a moment while I do that. Yeah, looking through the source code of very successful Python projects, open source projects, is tremendously educational. Let's see, one moment, just looking here.
What's the point of making a deep copy of itself in the init?
So this class has methods that will modify the data frame or the information in the data frame. So, filter steps or something like that. And so if you ever want to compare what the original data look like, it's nice to have a copy handy. So I just wanted to save the original state for later comparison.
But at that point, does it have data in it?
Yeah. It's being pulled. Yeah,
or
it's
what you're sending in. I missed the beginning of the conversation, sorry.
Yeah, so when we initialize a moo, we're starting with like a CSV file or a dictionary or something that has data already. So at that point, it does have data.
Where does it get assigned? It's just it's already in a data frame.
The information?
Yeah, when you
it exists before
like
this
an
code is
init
even
where you're actually initializing one of these moo objects.
I can pull up the tests. Let's see.
By the way, I found the line in the Pandas source code where hard codes returning an actual data frame class.
Oh, really?
Yeah.
Can you share that window?
Yeah, I just put the link in the Zoom chat.
Oh, okay.
And I think they could just replace. So yeah, Tim, if you want to have the accolades of submitting a patch to the Pandas project, you can. I think line 634 there, they could do a diff. I think they could return, instead it says return capital data, capital frame. I think instead it could just say return self.dunder class.
Yeah.
I think that would not break anything else, though of course you would want to verify that by running the full test suite. It'd be interesting if it did break something else. But essentially, that's what it like. Looking at the other links, which went to a different class called ND frame, which is basically a base class at data frame, and I guess some other things inherit from. Yeah, if you trace the code, that's where it goes to. This underscore constructor method, not dunder, but single underscore constructor on line 633 of this of frame.py here. Yeah.
Where did you send the reference to the comment?
I put it in the Zoom chat, I think. Did I? Let me check. Yeah, it's the last thing I just put in the Zoom chat. You see it?
Yep.
And that'll load up line 633 of a file called frame.py in the pandas repository.
Mhm.
And see, yeah, so in the next line, 634 says return data frame. If it said return self.dunder class, then we probably would have not had this whole conversation today if it did that.
Yeah. Yeah.
So cool. I'm really glad we went down this rabbit hole. This was very interesting, wasn't it?
It is to me, but I hope I didn't bore everyone else.
Yeah, I wasn't bored. Forget it.
Can you
If
go back to
anybody's
that-
bored, Tim, then that's their problem.
Yeah. Can you go back to that read CSV class method?
Read CSV. So you mean how the object is instantiated, or you
Yeah.
want to see the definition of the class method?
I want to see the definition of the class method.
Here.
So couldn't you just create another object from the same things and then set object.original equal to that copy? Instead
So
of doing the Steve
remember this.
copy?
This code works as is. The problem was doing it in this init. This is trickier. So we can't get a moo object from this deep copy, but we can from here because we're using a class method.
Yeah, I just don't always trust deep copy if you've got something special in there that it's hard for it to follow.
Yeah, probably because it's
Just made-
implementing a very bespoke Dunder deep copy under the hood. That's probably why it's not trustworthy.
But if you just made another class off the same data and then set that to be your object original, that would be another way to address this.
Did we try that?
So you're
I'm basically saying
Mhm.
make two of those classes and then set the one you're returning, set the dot original on that to be the one of the two.
I didn't quite follow that.
Just create the class twice inside your class
You
method.
create the class or create an instance of the class, two instances of the
Instance
class?
of the class twice. So you create two
No.
instances.
Well, let's remember we're talking about pandas data frames, i.e. potentially big data. So we're, creating multiple instances of massive data container objects is,
But
you want
the way we're
what he's doing with the deep copy.
yeah, right here we're doing the same thing with the deep copy. That's for sure.
right. Oh, I thought you meant an additional one on top of that. Is that maybe you did not mean that? You're just saying making it
So
earlier, basically.
I think he's saying if you duplicate this line and you call this one object 2, so we have two initializations and they create two different objects. And then we just store one of those objects here, like object 2. And we
You
return
can just
object
use
1.
copy. No, I'm kidding. I was kidding. Yeah. Okay, I see what you're saying. And so you've saved the state.
Without using deep
It's
copy.
not exactly, all it does is it doesn't have path and date.
Well, yeah, you'd want to include
Original is, I guess, unset. I think it's just a lot cleaner to just store the data, cooperate with the situation and store the data frame object. But yeah, that would work too, I think. I think it would work, yeah. It just makes the code more a little more complicated.
Yeah.
Okay. Anything else we can do for you today, Tim?
No, that's it. Thank you.
All right.